This is a compact, one-wide tileable shulker box loader. We load empty or not full shulker boxes here. Then we have to prime the machine using this button. Stuff we want to store into the shulker boxes come in through this hopper, then gets loaded into the shulker box, and when the box is completely full, it's broken and it ends up in this hopper and then in this barrel. Let me demonstrate. I here have a shulker box that is almost full of redstone, but not entirely. Take a bunch of them. Then we dump some redstone here. We unfortunately need to start it manually for the first time, but then it will load the boxes automatically. And now completely full boxes end up here. The only thing that might not be obvious from looking at it like this is that this is a dispenser and this is just a dropper. And the dropper is facing into the dispenser and the dispenser is facing up. Everything else should be relatively clear from looking at it like this. I'll show you how to build it at the end, but I want to go through the design process first. I needed a compact shulker box loader for my piglin farm because I didn't leave enough space under the item sorter to fit a more traditional design like Ilmangos that I have used in the past. And because I was way too lazy to move the item sorters just a few blocks up. Instead, I sat down in creative and thought, how hard could it be? Turns out, it's pretty hard. This took a long time to figure out, but I'm quite pleased with the result. Let's go through the design process to explain what's actually going on here. First, we need a mechanism to detect when the shulker box is full. When we insert items into this box here, the signal strength will update up to 15 times before the box is actually full. One way to solve that is to feed a full signal strength to the side of the comparator here, and this way it will not turn on the signal until the box is full. So like this. Now it's full. If I just remove something from here, the signal strength is 0. I put it back, signal strength is 15. But this breaks our design criteria because we need something that is 1 wide. Fortunately, I have recently seen a trick that someone did. And I'm sorry I don't remember who it was, but if we keep this signal at level 14 through some other source, it will only update to 15 when 15 is coming out of the comparator, and otherwise it will not update. So something like this, for example. We now have signal strength 14 regardless of how much stuff is in the shulker box. So I can remove things from here. But then I fill it, nothing is happening yet, and now it updates. So this way we can detect when the box is full or not. Great, so now we have fullness detection. We will call this side here, where the comparator is, we'll call it the front, just because. We have 3 more sides around the shulker box where we can put other blocks. We need a hopper that feeds the box, a dispenser that dispenses new boxes, a piston that breaks the box, and a hopper to pick up broken boxes. Uh-oh, that's 4 blocks, and we only have space for 3. But fortunately, we can put the hopper that picks up the broken boxes under this comparator. And that actually solves another problem, because that means that the piston that breaks the box has to be on the back. There are no other options, so we just put it here somehow. And the hopper that feeds items into the shulker box has to be above because it cannot be below. And that only leaves then the dispenser that dispenses new boxes below. There are no other way to arrange this, at least if we're doing things this way. And let me put the hopper here, just so we have it there. And you have to imagine that there are more hoppers here. This is not just a lone hopper that is hanging out alone in space. There is probably a sorting system above here or something like that. So we can't route the signal just above it, or maybe we could, but that would require an incredible structure of observers or something, and so that cannot be done. We need to feed the signal somehow to the other side. We could theoretically go below, but the way we need this mechanism needs to work is that the piston activates first and then the dispenser. So if we fed the signal to break the box underneath, that would mean that we first have to bypass the dispenser somehow, activate the piston, and then move the signal back to the dispenser. It feels too complicated and unnecessary. So let's see if we can move the signal through these hoppers here. And it turns out this is very simple. We just put an observer here. This observer will now power this hopper, and we put another observer here that detects when the hopper is powered, and we can just add a piston here to see what's going on. And then whenever something is happening on this side, we get a signal on the other side. Great. So now we have this. So now we need to activate this piston somehow. This should be relatively easy. Maybe something like this. And the piston is breaking the box. So some way to activate the dispenser and we're home free, right? An observer like this. An observer like this. An observer like this. Put back the redstone dust, and we can hear that the dispenser is clicking after the piston has fired. That should be more or less fine. And we can add a few shulker boxes into this dispenser to see that this actually works. And I'm just triggering the system manually to show that the shulker boxes get broken, and this kind of works. We have a problem though, because the shulker boxes are falling out. And the reason for that is that this block is powered, so it's locking the hopper. We can't have that. Also, we have another problem, and it is that there is no good access to this dispenser. And to make a long story short, I approached this problem like monkeys with typewriters, if you heard about that kind of story. I started to just rearranging all the blocks randomly and adding droppers, moving the observers and stuff like that until I came up with this design. This design works because the sticky piston with the observer moves the observer and it powers this dispenser, but that also powers the dropper to push new boxes into the dispenser. We move the piston forward, that feeds a new box into the dispenser, then when the piston moves back, the observer fires again, and powering the dropper, we also power the dispenser, which dispenses a new box. And rather than using a torch, which you probably even have seen in my piglin farm, I'm still using that there. I just 10 minutes ago I figured out that, oh, I can just have a redstone block here and we don't need anything above here, because the design in my piglin farm was doing something like this. And this was a block like this. This is the same thing, except that with a redstone block, this is just slightly more compact. So how do we build this? Take a dispenser, place it like this. Take a dropper, place it facing into the dispenser. Couple of hoppers here. Take a barrel here and a barrel here. Stick a piston. hopper, comparator, any solid block, block of redstone, to redstone dust. Carefully place an observer against the redstone dust like this. Place a temporary block here. Hopper, and another hopper because you will probably need it in the future. An observer looking at this hopper. An observer looking up here. Remove the temporary block. Also, add a button here so we can trigger this machine when it's freshly loaded with shulker boxes. Add stuff here. Bam. Start it. And there we go. I hope that my explanation was clear enough, but if you have any questions, just ask them in the comments and I'll try to answer everything I can. Thanks for watching. Bye!